Welcome everyone, my name is Akeem Brown and today I'll be presenting an analysis of the Three Mile Island disaster which occurred in Middletown, Pennsylvania. So this event was a pivotal moment in nuclear safety history with long-lasting environmental and societal impacts. Alright, our purpose and objectives today, we're going to analyze the environmental and societal effects of radiation waste from TMI. We're going to provide an overview of the disaster and its aftermath. We're going to explore radiation waste data using graphical and spatial representations, and then we're going to identify lessons learned in nuclear safety and disaster management. All right, and here's a roadmap of our presentation. We're going to first look at the background of events, the radiation levels over time, radiation coverage and impacts, environmental contamination breakdown, and then we're going to have a summary of everything. So here we go. Here is the background of events. So the 3 Mile Island incident occurred on March 28th, 1979. Due to a combination of mechanical and human errors, a coolant system failure caused the partial meltdown of the Unit 2 reactor. Though most radiation remained contained, small amounts were released into the atmosphere, which led to widespread fear and mistrust of nuclear energy. So as you can see here, is that in 1979 there was a reactor failure, then a radiation release, evacuation advisory, and then a crisis management, and then cleanup happened in 1980, and impact on 1993. All right, here we can see the radiation levels over time. So the graph that we see here illustrates radiation levels from 1979 to the 2000s. So a significant spike in radiation was detected during the event at around 1.5 in 1979, and then over time, due to containment and cleanup efforts, levels gradually declined to background radiation levels by around 2000. So it shows the effectiveness of mitigation and long-term monitoring efforts. All right, and here we are looking at the radiation coverage over time. So radiation was most intense within a 5 mile radius of the plant, and then beyond this, the radiation impact was minimal but measurable in certain areas. We can see that in 1979, the radiation coverage was around 48%. In 1980, it dropped down to 25, until in the 2000s, it became 3%. So it shows how the localized spread influenced evacuation measures. Here we have our radiation impact map. So it represents the geographical spread of radiation released during the 3 Mile Island disaster. As I said before, the focus is on radiation levels within a 5 mile radius of the plant and beyond. So the highest radiation concentrations were detected within the immediate vicinity of the plant, as we see here, specifically within the 5 mile evacuation zone. So these levels led to immediate health and environmental concerns. And then beyond the 5 mile radius, radiation levels dropped significantly as distance from the plant increased. And monitoring showed trace radiation in surrounding counties, but levels were within the federally permissible exposure limits. And pregnant women and children were prioritized for evacuation due to their increased vulnerability to radiation exposure. And the map highlights evacuation zones in areas where radiation monitoring was most intensified. Spatial data like this was critical for implementing evacuation plans and allocating resources, and it also guided long-term studies on cancer rates and other health impacts among the affected populations. So areas with even trace radiation levels were included in long-term environmental studies, and cleanup efforts were prioritized in the most impacted zones, focusing on soil and water decontamination. So the radiation impact map demonstrates how spatial analysis is vital for emergency response and long-term disaster management, and of course it reinforced the needs for robust monitoring and swift action in mitigating nuclear disasters. Now here we have our environmental contamination breakdown. Here we see that airborne radiation accounted for 40% of contamination, water for 35%, and soil for, of course, the 25%. Immediate effects were seen in air contamination, but long term effects impacted water and soil. And the findings emphasize the need for robust cleanup operations and environmental safeguards. And here's a summary. So, the disaster caused a partial meltdown and significant radiation release, though most of it was localized. Public health impacts were notable within the 5 miles, with increased cancer rates observed, and environmental monitoring and cleanup lasted over a decade. The event led to stricter regulations and oversight in nuclear safety. So, the 3 Mile Island disaster serves as a cautionary tale, highlighting the critical importance of safety protocols and emergency preparedness in nuclear energy. And here are my references. Thank you.